Oh, hello, Y11. Welcome to your homework feedback session video for pages 142 to 146. Similar as always, please get a green pen. Please give yourself a mark for all the questions you got correct. Write down the correct answer in green for the question you got wrong. Again, I'm going to do it in less than 15 minutes. À l'attaque. First one's about strong acids and weak acids. Below are some acids listed in order of strength. Hydrochloric is a strong acid, while carbonic acid is a weak acid. Explain the difference between a strong acid and a weak acid. For this one, you need to give me the definition of a strong acid, which is an acid that fully dissociates in water, whereas a weak acid is an acid that only partially dissociates in water. So this is what you need to write. Yeah, that means that a strong acid is going to release all its H plus ions in solution, whereas a weak acid is only going to release some H plus ions. Describe and explain the difference you would expect to find in the pH value of a 1 mole per decimeter cube solution of nitric acid, which is a strong acid, and a 1 mole per decimeter cube solution of ethanoic acid, which is a weaker acid. The solution of nitric acid is going to be more acidic, so it's going to have a lower pH than the solution of ethanoic acid. Okay, so the nitric acid will release more H plus ions in the solution, and the more H plus ions you have in the solution, the lower the pH. A 0.01 mole per dm cube solution of hydrochloric acid has a pH of 2. Predict the pH of a 0.001 mole per decimeter cube solution of hydrochloric acid. So the solution is diluted 10 times. Okay, so you're going to have 10 times less H plus ions in your solution. So the pH is going to be 3. When the concentration of H plus is divided by 10, the pH increases by 1. A solution of citric acid in a beaker has a pH of 3. Which of the following would increase the pH, would make it less acidic? Tick 3 boxes that apply. Adding citric acid with a higher concentration to the beaker, that would make it more acidic, so lower pH. That's not good. Adding water to the beaker, that would decrease the concentration. That would also decrease the concentration of H plus, so it would increase the pH, making it less acidic. That would be good. Adding ethanoic acid to the beaker at the same concentration as the citric acid. If you look at what we saw before, the ethanoic acid is less acidic than the citric acid. So that would also increase the pH, making it more or less acidic. Changing the citric acid to carbonic acid of the same concentration, that would work, because if you look at the previous page, the carbonic acid is a weaker acid than the citric acid. Therefore, a solution with the same concentration would be less acidic, increasing the pH. So the second, third, and sixth options were correct. Next, reactions of acids. Acid can react with bases and alkalis. What type of reaction occurs when an acid reacts with an alkali? Remember, this is called neutralization. Okay, this is it. This is the name. The students had 2 spatulas of zinc carbonate into a beaker of dilute hydrochloric acid. Draw one line to connect the observation you would expect during this reaction with the explanation for that observation. You would see some fizzing, because when you react a metal carbonate with an acid, you're going to make salt, water, and carbon dioxide. And if you produce carbon dioxide, you will see some bubbles. Here we go. This is the only observation you will make. Then, acids can react with metal oxides and metal hydroxides to make metal salt and water. Write a word equation for the reaction of sulfuric acid and lithium hydroxide. So your reactant, sulfuric acid, lithium hydroxide, acid plus alkali, is going to make a salt called lithium sulfate, because sulfuric acid makes metal sulfate, and water. Okay, this is what you had to write. Complete and balance the symbol equation for the reaction of sulfuric acid and lithium hydroxide. Here we go. So here you have to be careful, because sulfate is SO4 2-, lithium belongs to group 1, so it's Li+. So you need 2 lithium for 1 SO4 2-, hence the formula Li2SO4. So once you have this, you have to balance the number of lithium. So we need two lithium on the left as well as on the right, so 2 LiOH, which means that we're going to form 2 molecules of water. And this is how you balance this equation. So here the hard bit is to write down the formula of the compound lithium sulfate. Yeah, you need to know that. SO4 2 minus, so Li2SO4. Acids can also react with metal carbonate. Fact: compare the product of the reaction between sulfuric acid and lithium carbonate with the product of reaction between sulfuric acid and lithium hydroxide. So you're going to make exactly the same salt. You're also going to make water, but in addition to it, you're going to produce carbon dioxide. Here we go. So same product, and when you're reacting lithium carbonate, you're also going to make carbon dioxide, CO2. Soluble metal salt can be made from the reaction of acids and metal oxides. Fact: zinc chloride can be made from the reaction of zinc oxide and hydrochloric acid. Describe a laboratory method to produce pure crystals of zinc chloride using this reaction. So first you're going to have some hydrochloric acid, in the beaker, and you're going to add zinc oxide, spatula by spatula, until the reaction stops, and you have some black powder left at the bottom of your beaker. You want zinc oxide to be in excess because you want to react all your acid. To make this step a bit quicker, you can gently warm. Then you're going to remove the excess zinc oxide, which is the insoluble black powder at the bottom, using a filter funnel. Then you're going to heat, so you're going to get a solution of zinc chloride after filtration, and you need to remove the water to get pure crystals. So you're going to heat the zinc chloride solution to evaporate the water, and then you're going to leave it to cool, and you can filter and dry the crystals that form, okay? Or you can let all the water evaporate on the windowsill. And you have pure crystals of zinc chloride at the end. Suggest an alternative to zinc oxide that would also react with hydrochloric acid to form the desired product, which is zinc chloride. You could also use zinc carbonate. Okay, both zinc carbonate and zinc oxide would make zinc chloride in the presence of hydrochloric acid. The student is given 3 different unlabeled solutions. One contains sodium hydroxide, an alkali. One contains sodium carbonate, and one contains a sodium salt. Use your knowledge of chemical reaction to describe experiments that a student could do to decide which solution is which. Explain how your experiments would allow the students to identify the solutions, clearly describe the reactant and product of any reaction you include. So you could add a few drops of universal indicator to a sample of your solutions. If the universal indicator turns green, the solution is a sodium salt solution. If your solution turns blue, you have sodium hydroxide. And here we go. Then add a few drops, add a few drops of universal indicator to the solution and some dilute acid. The solution containing sodium carbonate will fizz because acid plus metal carbonate make salt, water, and carbon dioxide. So this one will bubble. The other one will not bubble. The solution containing sodium hydroxide will react with acid. The universal indicator will go from blue to green without fizzing. And acid plus sodium hydroxide goes to sodium, salt, and water. Here we go. And the sodium salt would not react at all. Metals can be placed in order of reactivity based on how vigorously they react with acids. Write a word equation for the reaction of magnesium with hydrochloric acid. MASH, metal plus acid makes salt plus hydrogen. So metal plus hydrochloric acid, the salt is magnesium chloride because the metal is magnesium, and hydrochloric acid makes metal chloride plus hydrogen. What does the reaction of magnesium with hydrochloric acid produce? Positive chloride ion, or positive hydrogen ion, or positive magnesium ions, or negative magnesium ions? The answer is the third one, okay? Because your hydrogen ion will react to form hydrogen H2, and your magnesium is going to form Mg2 plus ions in magnesium chloride. So the correct answer was positive magnesium ions. Because it's not negative, because magnesium loses 2 electrons. Each electron is negative, making the ion positive. Explain why iron reacts less vigorously with hydrochloric acid than magnesium does. That's because iron is lower down the reactivity series than magnesium. and iron loses electrons less easily than magnesium. Magnesium is really good at losing electrons. That's why it's so reactive. Name one metal that would react more vigorously with hydrochloric acid than magnesium does. So remember, all the elements of group 1 are very reactive, so they probably would be good. So potassium, sodium, and lithium. And you could also add calcium, which is even better than magnesium at losing electrons. So any of those would work. Next, some metals can react with water, the very reactive one. Write the general word equation for the reaction of a metal and water. Remember, your teacher probably did that in class with you, putting a piece of lithium or potassium or sodium in a big water trough. And when metal reacts with water, you're making a metal hydroxide plus hydrogen. And the way to prove it would be to do a squeaky pop test on the gas produced. Complete the symbol equation below for the reaction of calcium and water, including state symbol. So here, either you remember that calcium belongs to group 2, and it forms Ca2+, plus, and hydroxide is OH minus 1, so you need 2 OH minus, or you use the balance, the 2 in front of H2O to realize that you need 2 OH for each calcium. And you're forming CaOH2 with the bracket, which is aqueous, it's going to be dissolved in the solution, plus H2, which is the gas. Suggest a metal which will react more vigorously with water than calcium. Explain your answer. Potassium, because it's higher in the reactivity series than calcium. It loses electron more easily. Put the metals sodium, zinc, and potassium in order of reactivity. So the most vigorous, you need to remember this, is potassium, followed by sodium, and zinc is last. Okay, let's go quick. A student investigated the reaction of some metals and found the result shown in table 1. Lithium or magnesium form positive ions more easily. So if you look at lithium and water, you have a very vigorous reaction, whereas magnesium has a few bubbles, so it reacts very slowly. Therefore, lithium is more reactive, and it's going to lose the electrons quicker or more easily than magnesium. Predict what the students would have seen if they had added sodium to water, a very vigorous reaction that may have caught on fire. And the sodium would have disappeared. So exactly the same as lithium, but even more vigorous. Next, put the metal calcium, copper, and lithium in order from most reactive to least reactive. Lithium, calcium, copper, based on the information provided in the previous table. Explain why it would be difficult to decide the order of reactive magnesium and zinc using this experiment. So if you look at all the data provided, they have very similar reaction. Okay, so they have exactly the same observation in the result table. So what we can do is react zinc with water and compare with the results obtained with magnesium. And that will tell you which one is more reactive. Okay. The other thing you could do is try and do a displacement reaction. So you would have a magnesium reacting with, a solution of, something. If there is a change in temperature, it means the reaction takes place. It means magnesium is more reactive than zinc. All right, guys, this is it for me and for today. Please make sure you keep on working hard on your science. Hope you enjoyed that, and I will, I wish you all the best. Take care. See ya.